Session 4.2 Measures of Spread. Last sessions, we know how to find the measures of center, means we focus the data in the middle. And these sessions, we want to know how to find the measure of variation, means we want to know how's the data spread out. First one, we're gonna know is gonna be the range. The range of some data values is given by R equal to largest observation minus the smallest observation. Means we want to look at the data, find out the maximum data minus the minimum data. That would be our range. Look at this example. Vehicle sales in April 2014. So we do have a set of the data here. And we want to know how to find the range in sales and explain what it means in this situation. So look at the formula. We need to look for the largest sales minus the smallest one. So look at the data. The largest one, the largest sales will be the General Motors. Okay, that will be this number minus the smallest one. The smallest one will be the Subaru. Okay, will be this guy here. So plug in the formula and use your calculator to see what you guys get. You should got this number. This is gonna be the range in sales. Now we need to explain what it means in this situation. Since we got the range is 213,993 vehicles, that means the spread of the vehicle sales of the automaker is quite large. Okay, we have really high range in here. Okay, standard deviation. The measure of the variation for the second one will be the standard deviation. We need to know how to use the formula to find the standard deviation. And you can see we have two formula here. And then both of them is for you guys finding the standard deviation. And you can see we're gonna use the notation of S. Okay, the S here means the sample standard deviation. Okay, sample standard deviation. You only need to know one of the formula to find the standard deviation, and I will be using the example to show you guys how to use each of the formula. Again, you only need to pick one of the formula. You're gonna get the same answer. Okay, what is the meaning of the standard deviation? The standard deviation measures the spread. The greater the spread, the greater the standard deviation will be. So standard deviation is measure of how far the values in a data set are from the mean. Okay, this is for you guys compare like two set of the data, how's the data spread out. Okay, example, finding the standard deviation, the levels of cholesterol in milligrams in the equivalent of 1/8 of a 14-inch cheese pizza are sold in the table below. For 4 pizza companies, find the standard deviation of the cholesterol levels. Even though California Pizza Kitchen's 5 cheese plus fresh tomato pizza has a topping other than cheese, we include it in the group of the data because tomato does not have cholesterol. Find the standard deviation for the data. Okay, first, every time when we want to find the standard deviation, we need to know how to find the mean first. Okay, so remember how to find the mean? Remember the formula? You want to add up all the data and then divide by the number of the data. Remember, this is a summation notation, means you want to add it up all the data here. And then how many data do we have? We have 1, 2, 3, 4. Okay, use your calculator to see what do you guys get for the mean for the cholesterol level. You should get 28. Okay, the first step to finding the standard deviation will be look for the mean. Okay, so the mean is going to be 28. And then we do have a two formula. So I'm going to show you guys how to use this formula first. And in order to using this formula, we're going to create a chart here. Okay, we have the x and the x squared. The x here, this is represent your data value. So it's going to be here. You do have a 4 data value. So we're going to write it down from here. Okay, and then x squared means you want to take square of the x in here. So 30 times 30, you could get 900. Okay, I want you guys use the calculator, fill it out this chart here. Okay, take square for each data value, and then the total, I need you guys add it all up from here, and then add it all up from here. Okay, check your work. You should get this number. Okay, just take square for the x, for each values of the x. And then find out the total. So you want to add it all up for this guy. You should get 112. Okay, summation of x means sum of all the datas in here. And then sum of all the datas from here, you could get this number, summation of x squared. Now we're gonna look at the formula. The n here represent number of the data. So we have 1, 2, 3, 4. So your n is equal to 4. And then you have the summation x here. You're gonna plug into here. Okay, summation x will be equal to 112. Make sure you will have a 112 and then square. And then this guy, the summation x squared will be from here. Okay, so plug it in and plug in n equal to 4. You will have this one. Okay, now use your calculator to simplify it. You could get this number divided square root of 95.3333. So you should find the sample standard deviation will be equal to 9.7639 here. Okay, we still keep the units, that's called milligram. We just wrote it down. So the standard deviation is approximately 9.8 milligrams. Okay, we want to 1 decimal space and the 6 is greater than 5. So we're going to add 1 from here. So it's going to be 9.8 milligrams. So this is how we find the sample standard deviation. Use this formula. Okay, one more time. Create the chart here. Write down the value of the x. Take the square for each of the data. Find out the summation. And then plug in back to your formula. And this is called the sample standard deviation. Okay, method 2. We're going to use the second formula here. And this formula, again, we're going to create the chart, but this one a little bit complicated, okay, compared to the previous one. So again, the x, this is talking about the data value. You're going to plug in the data. And remember, we already find out the mean. Okay, we already find out the mean. That will be 28. Now, we'll be using the data values minus the sample mean. So subtract these two guys. You're going to get the 2 here. And then after you subtract it, you want to take the square. Okay, so 2 squared, that will be equal to 4. Okay, again, use your calculator. Try to finish this chart here, and at the end here, I want you guys find out the total. Okay, add it all up this number. Okay, check your work. Okay, just subtract it, find out the difference, and then take square of this number. And then add it up. You should find the total. Okay, and this one, you have this guy here, that will be equal to your formula on the top. So plug it in. Okay, again, your n is equal to 4 here. So you have a 4 data. Use the calculator to simplify it. You're gonna get square root of 95.3333. Take the square root. Okay, you should get the same answer. Okay, we're gonna get exactly the same answer using the method 1. Again, I showed you guys like 2 formulas. You only need to pick one method. Okay, either using the method 1 formula or the method 2 formula. So now we know how to find the mean, the range, and also the standard deviation. Okay, next example. Okay, comparing means and standard deviations of 2 distributions. A household suffers from food insecurity if at some point in the year the household eats less, goes hungry, or eats less nutritional meals because there is not enough money for food. The percentage of households suffering from food insecurity are shown in the table for the West, North, Central, and Pacific states. So we have a 2 set of the data. The first set of the data will be the West, North, Central state. Second set of the data will be the Pacific states. Okay, Pacific states. So 2 set of the data. And then they already help us to find out the mean and the standard deviation. Okay, you could see the n here. N is represent the sample size. Means how many data do we have. So you could double check for it. For the West, North, Central, we have a 7 data. 1, 2, 3, 4, 5, 6, 7. And for the Pacific state, we have 1, 2, 3, 4, 5 data. They find out the mean. They find out the standard deviation also. Okay, what do they mean in this situation? First, you could look at the mean for the West, North, Central states. They do have a 12.67%. And for the Pacific, we have 15.22%. So you could know that for the West, North, Central states tend to have a lower percentage of the household with food insecurity than a Pacific state, okay, because the mean is lower. And for the standard deviation, for the West, North, Central state, we have a 2.98%. Rather than the Pacific state, we only have about like 1.2%. So we know that we have a more variation of the West, North, Central distribution compared with the Pacific one. Means the data for the West, North, Central is more spread out, is far away from the mean compared with the Pacific distribution. Okay, in fact, the spread is so much larger for the West North Central distribution. One of the West North Central states has a larger percentage of the household with the food insecurity, about like 70.1%, than every one of the specific state. We verify this conclusion by inspecting the dot box solder. So you could look at the dot box in here. Okay, one dot represent one data. So this is the data set for the West North Central. Second one, this is the data for the Pacific states. You could see, look at the dot box, all the data is far away from the mean. Okay, the mean is about like 12.67. It's somewhere like here. So you could see all the data far away from the mean. But for the Pacific, the mean is going to be 15.22. So somewhere like here. So the data will be close to the mean compared with the West North Central. Okay, next one, that's called empirical rule. If the distribution is unimodal and symmetric, then the following statements are true. So approximately 68% of the data lie within one standard deviation of the mean. Okay, look at the picture. When we have a normal distribution, remember what is normal distribution? Frequency start low, reach to the maximum, and then go back to low again. And since this is a normal distribution, in the middle here, we consider this is gonna be the mean. Okay, it can be the sample mean or population mean. Then when we plus minus one standard deviation, okay, when you add one standard deviation and subtract one standard deviation, by the empirical rule, we say here, this is represent about like 68% of your data. Okay, 68% of the data will within one standard deviation. And we do have about 95%. So 95%, that's including the 68% also. 95% of the data will be within two standard deviation. Okay, two standard deviation means the mean plus two standard deviation or the mean minus two standard deviation. So in this part here, that's including about 95% of the data. And then last one. Approximately 99.7% of the observation lies within 3 standard deviation. So when you plus or minus 3 standard deviation, this is including 99.7% of your data. Okay, this is by the empirical rule. But keep in mind that we can apply the empirical rule when the distribution is unimodal and asymmetric. In other words, we could say that will be the normal distribution. Okay, example. Find the mean of the standard deviation of distribution. So we have the picture with the IQ test in here. Okay, IQ test, IQ score. And we have the density histogram of the IQ test in here to display. So first, number one, I want you guys to find out the median. Okay, the M here stands for the median. And then look at the histogram. This is a density histogram. When we have the density histogram, the area of each rectangle here will be equal to the relative frequency on that cast level. Okay, one more time. So this is means from the cast interval from 70 to 84, we have the relative frequency equal to 0.14. And this is for the density histogram. So number one, we want to find out the median. And look at this distribution. This is a normal distribution. Remember we talked about it on the session 4.1. When we have the normal distribution, so the measure of the center will be in the middle. In the middle part here, that will be median equal to the mean equal to the mode. Okay, so right now we want to find the median. So in the middle part here, that will be 100. So median will be equal to 100. And then second one, we want to find the sample mean. Again, this is normal distribution, so the measure of the center will be in the middle here. And then the sample mean will be equal to 100 points also. Number 3, we want to estimate the sample standard deviation. So look at the picture. We have a 0.34, 0.34. When you add it up, that is 68%, right? 68%. Okay, so remember the picture of the empirical rule, 34, which is about like 68%. And when we have the normal distribution, 68% of the data were within one standard deviation. Okay, so this is a mean plus one standard deviation or minus one standard deviation. So right now we want to find out the sample standard deviation. We're going to look at here. So this is the mean, and this is going to be the mean plus one standard deviation. So we could find out the difference from here, which is going to be 115 minus 100. That will be equal to 15. Okay, unusual observation. This is talking about we have an unusual data. Okay, unusual observation. If a distribution is unimodal and symmetric, the answer lies with the empirical rule, which states that 95% of the data are within 2 standard deviation of the mean. And this means that only 5% of the observation are more than 2 standard deviation are from the mean. So if a data is more than 2 standard deviation away from the mean, we refer to the data as unusual. Okay, we want to find out the usual or unusual value. So look at this picture again. So 95% talking about within 2 standard deviation. Okay, within 2 standard deviation. So if the data outside of this 95% will be like somewhere like here or somewhere like here, we consider the data will be unusual. Okay, or you could find out the maximum usual or the minimum usual. Maximum usual will be the mean plus 2 times the standard deviation, which means somewhere like here. Okay, mean plus 2 standard deviation. We call this as a maximum usual. And here, the mean minus 2 standard deviation, we consider this as the minimum usual. So you could think about it. If your data lying within this 95% here, we consider this as a usual value. But if your data below the minimum usual, we consider this as an unusual value. Or if your data above the maximum usual, we call this as an unusual data as well. Okay, I want you guys remember these two formulas, the maximum usual and the minimum usual. If you find the data values is above the maximum usual or the minimum usual, that means the data is unusual value. If your data is within the minimum and maximum usual, we consider the data is a usual value. Okay, example, determine whether an observation is unusual. Some songs play on Live 105 on April 18, 2014 have songs length with a mean of 232.9 seconds and a standard deviation of 49.6 seconds. One of the songs is a Lazy Eye, which lasts for 354 seconds. Is the song's length unusual? Okay, every time when we want to find out the usual or unusual value, you need to think about these two formulas, the maximum usual and minimum usual. Okay, they given the mean, they given the standard deviation. So first, I want you guys plug into the formula and find it out. Okay, check your work. Plug in the mean and the standard deviation. You should get 332.1 seconds. That would be the maximum usual. Minimum usual, you should get this number. Okay, look at the pictures again. So we have the maximum usual, that's a 332.1. So somewhere like here, right? The maximum usual. And for the minimum usual, that will be like here, 133.7. Okay, now we want to figure out if the songs The Lazy Eye last long for 354 seconds. So think about it. Is the song's length unusual? Look at the data, 354. So 354 should be somewhere like here, right? And if the data lying outside of the maximum usual, we consider this is going to be unusual value. Okay, we conclude that the song length is unusual for the songs played on the live 105 on this date. Okay, summary of measuring center and spread. So we learned the measure of the center and the measure of the spread. If you have a distribution is unimodal and symmetric. So unimodal and symmetric, you could think about the normal distribution, one marked and normal distribution. Then we want to use the mean as your measure of center. And we want to use the standard deviation to measure the spread. However, if your distribution is going to be skewed, you could think about skew to the left or skew to the right. Then we want to use the median, okay, using the median for the measure of the center, and we want to use the range, okay. Remember how to find the range, right? Maximum data minus the minimum data to find the measure of the spread. Okay, last one, variance. Variance is the square of the standard deviation. We learned how to find the standard deviation using the formula, right? So now we want to find the variance. Variance, it just means like you want to take square of your standard deviation. For example, let's say my standard deviation is equal to 2. So my variance will be take square of it, means like it's gonna be equal to 4. Or the standard deviation is equal to 3. So when we want to find the variance, when you take square of the standard deviation, 3 square means it's going to be equal to 9. So we're going to be using the earlier example that we finding the mean and also the standard deviation about the cholesterol levels in the pizza, in the cheese pizza. And this time we want to find the variance, okay? Find the variance. So we already find the standard deviation equal to 9.7639. So if we want to find the variance, we just need to take square of this guy. Okay, take square of this guy. So that will be 95.3. When we take square, we also want to square, we have the square unit. So the variance is 95.3 milligrams square. Okay, that's it for this session.